Hello everyone and welcome back. Today we will have two examples of first order homogeneous differential equations. The first one, dy over dx equal this fraction. And first we need to check if it is homogeneous or not. So what we do, we put every x kx and every y ky, and then see if the equation changed or still the same. So here k times k will be k squared, and this is kx over ky, so the k cancel with this k, and here we have k squared. Also here we factor out k squared, both they will be cancelled. K squared and k squared here. So this one will cancel with this one. And here the k will cancel with this. This is the same. So our equation didn't change. Then it is homogeneous. How to solve it? As we said in the last video, we solve it by using substitution. Let x equal yv. We derive both sides by using the product rule. Dx over, we derive dx with respect to dy, because this is our assumption. Y dv over dy plus v. This is equation 1. And so here we took the reciprocal of this equation, because we have dx over dy, not dy over dx. It changed to this form. And then we factor out y squared from here and y squared from here, and the y squared cancel with y squared, so we got this equation. And this is our equation: 1 plus e v squared plus 2v squared e v squared over 2v e v squared. Dx over dy from equation 1, this equation, equal y dv over dy. So we put it in the left side, and the right side is still the same. We integrate both sides of this equation. So here we have ln y equal ln, just to make sure. So here we have d1 plus e v squared equal 0 plus e v squared 2v dv. And this is the same as this. So we can integrate du over u. To integrate this, we should have du here. And here we have it. Let me write it down here. d1 plus e v squared equals 0 plus e v squared 2v dv. So this one integrate this, we should have du, the derivative of u. And here we have it, e to the v square and 2vd. This is the derivative of this term. So we will get ln y equal ln 1 plus ev square absolute plus c, the constant of integration. And here we raise both sides to e. Okay, we got this because this is the same as e, and here e to c, we call it k, another constant. So here our formula, y equal, and then we back substitution from our assumption x equal yv, so v equal x over y. This is v, and this is square. And this is the final formula for our solution. The second example, this one, dy over dx equal y over x, ln x minus ln y. And this is our initial condition, y equal to 3 at x equal 1. This example is application because there is a initial condition. And if you remember from the last video, if we leave the equation as it is, then it is not homogeneous, because we have special function like ln y, the special functions we said like ln y, sin y, e to the power y, and so on. But it needs a little work, so we're using the logarithm properties. We wrote this as in this form, ln x over y. Okay. So now it is homogeneous, because if we put every y, ky, and here ky, and here kx, the same here, so the equation is still the same. No, it doesn't change. This one cancel and this one cancel, and we still have the original equation. How to solve it? Again, we use substitution. So let y equal vx. This is opposite, our assumption is opposite of the first example. So here y equal vx, where v equal y over x. We use a product rule. We derive with respect to x. Both sides of this equation. dy over dx equal v plus x. And then let's say this is equation 1. So we put the right side of equation 1 in our equation here. So this one, we put this the right side of equation 1 and here, and we integrate both sides. Just a quick note how we did. So let u equal ln 1 over v minus 1, and du equal 1 over v times minus v minus 1 dv. And it will, so v will cancel the minus dv over v. This is how we did here du, sorry. So du equal minus dv over v. And then we put, so dv will be equal du minus duv, and then the v cancel with this, and it will be easy to integrate. But we use this substitution to get this integral. And here we have the integral of this equation. Here's our integral, ln all this equation. We multiplied both sides by minus, so this minus cancel, and we got here minus c1. Exponentiate both sides to solve for v, and e to the ln 1 over v equal, and here you see exponent both sides, so this one will be cancel, and we got ln 1 over v minus 1 equal, this minus will be here minus c1. So it will be like this, in this form, e and e minus 1. So here again it is another constant. We call it c, not c1. So c times equals c over x. Again, both sides, we take both sides to the base, to raise both sides to the base e, and we got this one, this equation. We moved the minus 1 to the other side, and then, so this will be, and we will have 1 over v equal e c over x plus 1. V equal this formula. And back substitution, in our substitution we said v equal y over x. So here we substitute for v here, y over x equal e minus c over x minus 1. Then y equal x is c over x minus 1. And to find c, we use our initial condition, which says y equal 3 at x equal 1, using initial condition. So every y we put 3, and every x we put 1 to find the constant c. So c equal minus 1 plus ln 3. And here is our final solution. And to find the range of validity, we should avoid x equals 0. Here, x doesn't equal 0 because all the other real numbers are okay. But and here the line here, x equals 0. But our initial condition says y equals 3 at x equal 1. So x here. So all this, the interval will be bigger than 0. Here, x equal 1. So here is our interval, bigger than 0 to less than infinity. Thank you for watching my channel. Please subscribe and give me your likes, and see you in the next video. In the next video, we will talk about Bernoulli differential equation. Have a good day.